This video covers section 9.5, adding, subtracting, and multiplying radical expressions. Objective 1, add or subtract radical expressions. Before we get started, let's talk about the practice problem. Number 1, add 5x cubed plus 9x cubed. Since they're like terms, we add their coefficients. 5 plus 9 is 14, x cubed. So this serves as a basis for adding what we call like radicals. When we add radical expressions, we look for like radicals. Since 5x cubed and 9x cubed are like terms, we add their coefficients and leave the variable part unchanged. If the radical expressions have the same radical, a square root of x, meaning they have the same square root and then the same radicand. So they both have a square root of x. We can add the 5 to the 9 and get 14 of the square root of x's. If you have cube roots of x plus 1, both of them having it, then we can add the coefficient 5 and 9, and it gives us 14 of those cube root of x plus 1s. So if your radicand and the index are exactly the same, square root of 13y, we add the coefficient 9 plus 4, which is 13, square root of 13y. If they all have a 4th root of 5 on them, then they're like radicals. There's a 1 plus 9, which is 10, minus 3, which is 7 of those 4th root of 5. Here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. 18 square root 19z minus 20 square root 19z. 18 minus 20 is negative 2 of the square root 19z. Three 5th root 5x minus 1 of those 5th root 5x minus 3 of them. So we have 3 minus 1 minus 3. That's 3 minus 1, which is 2, minus 3, which is negative 1. This gives us negative 5th root of 5x. Example 2. Add or subtract is indicated and assume that all variables are greater than or equal to 0. We do not have the same radicand underneath these square roots. So we need to simplify these first. Square root of 12 is the square root of 4 times 3, or 2 square root of 3. So we have 3 times 2, which is 6 square root of 3 plus 7 square root of 3. Now we have the same radicand. 6 of the square root of 3 plus 7 of the square root of 3 is 13 square root of 3. Letter B, we don't have like terms here. So the square root of 20 is square root of 4 times square root of 5, or 2 square root of 5x. Now I need to produce the square root of 5x from the square root of 5x cubed. With an x cubed in our square root, we take 3 and divide it by the index 2, and it gives us 1 that comes out and 1 that's going to stay under, and the 5 stays under with it. Now we have 3x times 2, 6x square root of 5x minus 7x square root of 5x. Since they both have that same radical, we apply the operator to the coefficients. 6x minus 7x which is negative x, and we still have the radical part, negative x square root 5x. Letter C, we don't have the same radical, so we simplify first. Square root of 8 is square root of 4 times 2, or 2 square root of 2. 27 is 9 times 3, or square root of 9 is 3, and the 3 stays under. And these are not like terms, so they'll stay as is. And here are 3 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. We first need to simplify the square root of 18. And since 18 is 9 times 2, we take the square root of the 9, that's the perfect square, and then the other piece stays under. Square root of 8. 8 is 4 times 2, and the square root of 4 is 2, and that other piece stays under. These get multiplied. 12 square root of 2 minus 6 square root of 2. We have a like radical, and so we apply it to the coefficient. 12 minus 6, which is 6 square root of 2. Letter B, we have negative 5x. We need to take the cube root of 54. 54 is 27 times 2. And so the cube root of 27 is 3. And the 2 and the x will stay underneath that radical. Cube root of 2. 2 can't go anywhere, but the x the fourth. 4 divided by 3 is 1x coming out. And 1x staying underneath next to that 2. Now we multiply these and get negative 15x cube root of 2x plus 7x cube root of 2x. Now that they both have the same like terms, negative 15 plus 7 is negative 8 x cube root of 2x. Letter C, 7 square root of 10 minus 6 square root of 3. Square root of 10 is simplified, square root of 3 is simplified, but they are not like radicals. So this is already simplified. Simplified already. Example 3. Add or subtract as indicated, assume all variables are greater than or equal to 0. So we're doing the same thing here, but we have higher roots. Cube root of 16x to the fourth. Cube root of 16, that's 8 times 2. And the cube root of 8 is 2. Cube root of x to the fourth. 4 divided by 3 is 1, and 1x stays under. Cube root of negative 2x. Negative 2 is negative 1 times 2, and the cube root of negative 1 is a negative 1. And we'll be left with cube root of 2x. plus cube root of 54. 54 is 27 times 2. And the cube root of 27 is 3, giving us 3 cube root of 2x. So we have 2x cube root of 2x. And that negative that came out is going to leave us with a 7x cube root of 2x. And then this gives us 3 cube root of 2x. And so now we add the like terms together. Only these two are like because this last one doesn't have an x on it. So we have 2 plus 7, which is 9, and then this variable part comes with it. Now we could say they're like terms by saying this coefficient's 9x and this coefficient's 3, and then say that the cube root of 2x is what makes them like, and then we get 9x plus 3. That would be the most simplified answer. And letter B, 3 times the 4th root of m to the 4th n minus 5m 8th root of n squared. We know the 4th root of m to the 4th is m. That'll leave us with the 4th root of n. The 8th root of n squared, it doesn't really look like it simplifies, but we can rewrite this as an exponent of 2/8, and then that's n to the 1/4, which really turns out to be the 4th root of n. So we can rewrite the 8th root of n squared as the 4th root of n. Now we have like terms. 3m 4th root of n minus 5m 4th root of n. So 3 minus 5 is negative 2, m 4th root of n. And here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. The cube root of 8 is 2, and the cube root of z to the 4th, 4 divided by 3 is 1, and 1z will stay under. The cube root of negative 27 is negative 3, and that z will stay under. The cube root of 125 is 5, and the z will stay under. So we have 2z, cube root of z, and this becomes plus 6z cube root of z plus 5 cube root of z. These two add and give us 8z cube root of z, and this gives me 5 cube root of z. Now that they both have cube roots of z's, I can rewrite this as 8z plus 5. And letter B, the square root of 25 is 5, and the m is going to stay under. minus 3, that's the fourth root of m squared. The fourth root of m squared is m to the 2/4, or m to the 1/2, which is the square root of m. So that's minus 3 square root of m. And now 5 minus 3 is 2 square root of m. This concludes the video for section 9.5, adding, subtracting, and multiplying radical expressions. Objective 1, add or subtract radical expressions.